recording. So tonight when you watch this, hopefully you'll see yourself on film. Okay, 9, 24, 18. Number 1. Given the polynomial f of x equals a negative 3x to the third plus x to the fifth plus 2. Rewrite it in standard form. Okay, I can do that. F of x is equal to biggest exponent, right? Biggest exponent, x to the fifth. Then next biggest, minus 3x to the third plus 2. There it is in standard form. Largest exponent all the way down, okay? Now, the degree is the biggest exponent. So the degree of this one is 5. The leading coefficient is the number in front of the biggest term. There's an invisible 1. We don't need to write it, but there's an invisible 1. That's my leading coefficient. The local max and local min. I'm going to need to graph it. Okay? So my window that we had was, if I go to my window first, I used negative 5 to 5 and negative 5 to 5. I'm going to keep that window. I think that's going to work for me. So I'm going to go ahead and go to my y equals, clear this, and I'll type it in slowly. I'm going to, hey Devin, grab a review right here. Okay, come here Devin. Yeah. So, you're welcome. So let's graph it. So I'm going to put in x to the fifth, subtract 3x to the third. Whoops, clear, clear, clear. Start again. X to the fifth over arrow. Subtract 3x to the third over arrow plus 2. Okay? It's in my calculator. Am I going too fast? Okay, I'll wait for you. Okay. Brian, you guys got it in?
Yeah.
Did you get it? Yeah, so once you get that, you push over arrow, it pops down, okay? And then you're going to go subtract 3x to the over arrow plus 2, okay? Okay. All right, let's push graph. So we push graph and see what we get, okay? Now, okay, so okay, there we go. Now, max or min. First of all, let me make a rough sketch of this. It's going to look something like, goes up, comes down, has a little bend of an inflection point, goes down, back up. Okay, so let's see if I can find my max. Okay, local max, second, calculate. Let's look for our maximum. Okay, am I going slowly enough? Enter. My maximum is up here, so left-hand bound. Take the cursor to the left-hand side of your maximum, anywhere on the left-hand side. The cursor is blinking. I push enter, it locks it in. Take the cursor to the right-hand side of my maximum, anywhere as long as it's to the right hand of it. Okay, it's blinking. Push enter, lock it in. I'm telling the calculator where to look, so if I push enter, I get my maximum at a coordinate of about a negative 1.3 and about a 4.9. That's my local max. Now if I want my local min, I'll do the same thing. I'll go second, calculate. I'll go to my minimum, enter. My minimum's down over here, so I want to go to the left of it, so bring my cursor so I'm to the left of my minimum. Yeah, right about there is good. As long as anywhere, okay, enter, lock it in. Right hand bound, so I'll take it to the right hand side of my minimum, okay? Blinking cursor. As soon as I push enter, it's locked in. I've told my calculator where to look in between those two, so now I push guess. I don't need to guess, enter. And I get an answer about a 1.3, comma, negative 0.9, okay? Now, if I want to find out where it's increasing and decreasing, right? So increasing. Where is it going uphill? Where it's going uphill is in this region. It's going uphill, increasing, and it's also increasing here. Now it has to be the x values. So you have an x value right about here of negative 1.3. You've got an x value here of about a 1.3, okay? So it's increasing from negative infinity to negative 1.3, okay? And you can write that. If you want to say, you know, from negative infinity to negative 1.3, that's fine. And you can also say from 1.3 to infinity. That's okay also. I think that's one way you can write it, or I would write it, you could also write it as when x is less than 1.3 or x is greater than, that's a negative 1.3, or x is greater than a 1.3, okay? Both of those will work. As long as you tell me where it's going uphill. When is it increasing? Now it's decreasing, it's going downhill, here to here. So you could say, if you wanted to use words, decreasing, and I would take this, you could say from negative 1.3 to positive 1.3, it's decreasing, okay? As far as x's and sets, I like this. Negative 1.3 is less than x, which is less than 1.3. But you do not have to put it that way. You could just use words. I'm okay with anything as long as it's correct. Does that make sense? I'm okay with any notation as long as it's correct notation, okay? If you want to even write me a note, well, Mr. Davies, it's increasing from here to here, that's okay for me, okay? Got it? All right, let's keep moving on. Okay, number 2. So, in the figure, we're going to write an expression for perimeter and area. So the perimeter, let's see. So I'm missing some things. Watch carefully. This length is 2x plus 3, from there to there, right? And this length is 2x, from there to there. Okay? This length from here to here is x, but this length from here to here is a 2x plus 1, right? Which really makes this whole side here a 3x plus 1, doesn't it? That whole length there is a 3x plus 1. Now, if I want to do perimeter, I'm just going to add all the way around. So for perimeter, I'm going to go this plus this side plus this side plus this side plus this side plus this side, right? So I'm going to start in this corner, and I'm just going to add around. But let me just add the x's first. Okay, ready? 2 x's, 4, 5, 6, 7 x's, 8, 9, 10, 11, 12, 13, 14 x's. So the perimeter is going to be 14x plus, well, let's see. Let's check out the constants. I've got 3, 4, 5, 6, 7 plus 8. Okay, that's my perimeter. That's it. I just counted the x's all the way around and counted the numbers. Okay, thumbs up on that one. Okay, now area is a little bit different because area is always going to be length times width, right? So what I have is 2 rectangles. So I've got a rectangle here in green, and I've got another rectangle here in purple. So let's find the area of both. Let's find the area of both and add them together. So first of all, area 1. So this first rectangle has got a width of 2x plus 3 and a length of 3x plus 1, right? So it's going to be this times this, length times width. So the area then is going to be a 3x plus 1 times a 2x plus 3, right? Plus the area of the purple one, plus the area of the purple one. So the purple one is just 2x times x, right? Right? Just 2x times x. Yeah, exactly. Yep. So let's simplify it, okay? So I'm going to try and simplify my area. So I'm going to have a 6x squared plus a 9x plus a 2x
But wouldn't that work? 'Cause we're
plus
writing an
3.
expression,
It would, but I'm going to simplify it.
But we don't need to tomorrow.
No, I'd like you to. Plus a 2x squared. So I know it's kind of like all in here. It's all in here, but let's put it all together. 6x squared, 2x squared, 8x squared, right? 8x squared. 9x plus 2x is an 11x
What is that?
plus 3.
That plus.
Yeah, that's a plus 2x there, yeah. Okay, there's my area, simplified, okay, all the way through, okay? All right, number 3. You guys ready? Am I going too fast? I'll wait for you. But number 3 is the big FOIL, okay? So how do I know? There is nothing in between, is there? This one we're going to add. 4 we're going to subtract. But 3, there's no plus or minus. We're going to have to multiply. So I'm going to do this on a separate sheet of paper. So on number 3, I'm going to do 3 right over here, okay? So number 3, I'm going to have an x squared plus 4x minus 6 times an x squared minus x minus 4. Okay, are you ready? It's a big FOIL, right? Just a big, big multiplication problem. All right, here we go. X squared times x squared. X to the 4th, right? X squared minus x makes a minus x to the 3rd. X squared minus 4 makes a minus 4x squared, okay? Then I'm going to take the 4x times all 3 of these, okay? 4x times x squared is a 4x to the 3rd. Positive 4x to the 3rd I'm going to put right there. 4x times a negative x makes a negative 4x squared. And 4x times a negative 4 makes a negative 16x, okay? Now, one more big multiply. Negative 6 times all 3 of these. Negative 6 times x squared is a negative 6x squared. Negative 6 times a positive x, I'm sorry, negative 6 times a negative x makes a positive 6x. And finally, negative 6 times negative 4 is a positive 24. Okay, now I like to line them up because it makes it easier to add, right? Just add straight down. Things are lined up. So, x to the 4th plus 3x to the 3rd minus 14x squared minus 10x plus 24. Okay? It's a lot of work, right? Thumbs up? Okay, let's look at number 4. Am I going too fast? Okay, yeah. I'm going to write down number 4 while you're copying that down. How's that sound? 4 is 15x squared minus 2x minus 43x squared plus 16x minus 4. Okay, slide it up. Okay, number 4. Whenever I see subtract, I'm always very leery of double negatives. So this is my trick, is I like to bring the negative through. So I will rewrite this as a negative 43x squared minus 16x plus 4. Okay? Bring the negative through. Because I make mistakes on double negatives, and I don't want to do that. Okay? So now let me bring down the 15x squared minus 2x. Okay? Now I can just combine like terms. Let's see, is that a 28? That's 43. Clear. Yeah. That would be 43 minus 15. Yeah, it's 28. Okay, I'll wait for you, okay? So, to back up while we're waiting, whenever I subtract with the parentheses, I bring the negative through. So I don't make mistakes on double negatives. That's why I do it. Okay? You don't have to do that step, but that's what I do. Because I tend to make mistakes, okay? And now I'm just going to combine like terms. Okay, 15x squared minus a 28 minus a 43x squared makes a negative 28x squared. Minus 2x and a minus 16x makes a minus 18x. And then plus 4. Okay. Mac, how's that? Are you caught up?
Hold it.
I will. I definitely will. I know, I'm sorry, you guys. It's hard.
No, it's just a lot.
It is a lot of work. Okay. All right. Here we go. Number 5, the fun one. Pascal's triangle. 5 is the fun one. Okay, we've got a parentheses 2x plus 3 to the 4th power. So we're going to use Pascal's triangle. Okay. So I know anytime it's to the 4th power, it's like writing 2x plus 3 times 2x plus 3 times 2x plus 3 times 2x plus 3. I'm not going to do it that way. I'm not going to do a super big FOIL. I'm going to use Pascal's triangle. So I'm going to go to the 4th row of Pascal's triangle, and I'm going to start out with 1, 4, 6, 4, 1. Okay? Those are the coefficients from Pascal's triangle. Yeah, Cody? I know. Yeah, I know. We've done this one like 3 different times now, so hopefully that will be different on the test. So I like to do the A's and B's first, okay? Because it's easy for me if I start it with A to the 4th, B to the 3rd, whoops, A to the 3rd, A to the 2nd, A, and then no A's, right? And then we'll go on the back side and go B to the 4th, B3, B2, B to the 1, and then no B's, okay? With pluses in between. That's an A. Sorry about that, Brian. Kind of messy, huh? That's an A. Now, the problem's not about A's and B's. The problem's about 2x's and 3's. So we're going to let the 2x be A, and we'll let the 3 be the B, okay? And I'm just going to plug them in. So instead of writing A to the 4th, we'll write 2x in its place. So here we go. Here it starts to get big. So I've got a 1. And instead of writing A, I'm going to write 2x to the 4th. Plus 4. Instead of writing A, we're going to write 2x to the 3rd. Instead of writing B, we're going to write 3. Plus 6. Instead of writing A, I'm going to write 2x. Instead of writing B, I'm going to write 3. Plus, instead of writing A, 4, I'll write the A is 2x. Instead of writing B, I'll write 3 to the 3rd. Plus, instead of writing B, I'll write 3 to the 4th. So this problem's worth 3 points. So if you can get everything at least down to the spot right here, you're going to get 2 of the 3, okay? 2 of the 3. Okay, if you can get to here, you get 2 of the 3 points, right? Now, because the next part is a matter of just multiplying the numbers correctly, okay? So before you do anything, you got to listen. We got to take 2 to the 4th power. 2 times 2 is 4 times 2 is 8 times 2 is 16. So this is a 16x to the 4th. Okay? I don't need the 1. I don't need the 1. 2 to the 4th is 16 plus 4 times 2 to the 3rd. 2 times 2 is 4 times 2 is 8. X to the 3rd times a 3 plus 6 times 2 squared is
32x cubed, like, right?
Yeah.
Okay.
Yeah, you're ahead of me. Plus a 4x times a 9 plus 4 times 2x, 3 to the 3rd power is 27 plus 3 to the 4th power is 81. Okay, how am I doing? Now, I'm just going to use my calculator. I'm just going to multiply. I'm going to use my calculator, so I know I've got a 16x to the 4th. 4 times 8 times 3 is 96. Just multiply it out. X to the 3rd. 6 times 4 times 9, 216. X squared. Plus 4 times 2 times 27 is also 216x plus 81. Okay? There it is. And believe it or not, that is the fastest way to do it, unless you use photomath, right? But you can't use your phones tomorrow, so no photomath, okay? That's the answer. I know, I'm sorry, Katie. All right, how am I doing, okay? Okay, it's going to get easier now. We just did the hardest problem. We did. We've done the hardest problem, okay? We're done. All right, let's take a look at factoring, okay? Number 8. Number 8. So number 8, and again, I changed that one to a negative, so I've got a x cubed minus 2x squared minus 8x. Okay, don't forget to change that to a minus, okay? Okay, we're going to factor. So they have a common x, right? So I common factor out the x, and what's left inside is an x squared minus a 2x minus 8, okay? Now, I can factor again. And I'm going to factor this trinomial again, but the x is already out, so I'll leave the x out, okay? So the x has been factored out. Now, I'm going to use the multiples of negative 8 that add to make a negative 2, so go x minus 4, x plus 2. All right, 9. Did you ever notice that 6 and 7 were invisible? 6 and 7 were invisible. Yeah. Number 9. 64x to the third plus 125. Okay, ready? It's going to be this one here. You might not see it yet. I'm going to help you, but it's going to be this one here. It really is. You see, 64 is the same thing as 4 times 4 times 4. Okay? 64 is 4 times 4 times 4. So this can be rewritten as 4x to the third power. Okay? And 125 is the same thing as 5 times 5 times 5. Okay? Or plus 5 cubed. All right? Now, here's my A and here's my B. Now my formula is, up on the board, A cubed plus B cubed is equal to A plus B times an A squared minus an AB plus B squared, right? And I'll leave that up here. I'll leave that up here, okay? So in this case, A is going to be 4x and B is 5, okay? And I'm just going to plug my 4x and my 5 into the formula. 4x, 5, 4x squared, minus 4x times 5, plus 5 squared. So here we go. So the answer is going to be not A, but 4x plus B, which we said is 5, times A squared. So I'm going to square 4x squared. I'm going to get a 16x squared minus A times B. So if I multiply these two, I get a 20x plus B squared. So 5 squared is 25. That's my answer. Okay? That's it. Yeah, and you're done. That's all you do, okay? 5. B is 5. 5 squared is 25.
Yeah, but also A squared part.
Right.
Why are you supposed to do it?
So I squared the 4. That's easy, 16. But I can't square x squared is just x squared. Because I don't know what x is. Okay, let's look at 10, huh? Number 10. Am I doing okay? Am I going slowly enough? Yes? Okay. 10. All right. 3x cubed minus 27x. Okay, what do you see? Smart girl. What else do you see? 3. So let's pull out a 3 and an x. Okay? Right with that, take out a 3 and an x. Okay, what's left over? X squared minus 9, right? Now, x squared minus 9 can be factored again. But the 3x is already out there, so let's leave the 3x out. We're going to go x plus 3, x minus 3, and we're done. That might be one of the easiest ones on there, huh? Okay, 11. You ready for 11? All right, 11. We've got a 2x cubed plus a 3x squared minus a 2x minus a 3. Okay, ready? 4 terms, we group them. 4 terms, we're going to group them. So we're going to pair up these two and these two, okay? So, if I pair them up, in the first two, what do they have in common? They've got a x squared in common, right? So if I take out an x squared, what I'd be left with is a 2x plus 3, okay? The second two don't really have anything in common except for the negative, right? So if I take out the negative, in fact, let's take out a negative 1, and if I take out its negative, then it changes the signs, which is great because it's going to make it exactly like this, isn't it? So if I take out the negative, I'll have a 2x plus 3. Well, that's great because now I can factor again, okay? I can factor it again. So out of the two groups, what they have in common is a parentheses 2x plus 3. Factor that out. What's left over is an x squared minus 1. Awesome, except we can go one step further. Anybody see one more step? X plus 1, x plus 1, x minus 1. Okay, we can factor that one more time. Just like we factored that into x plus 3, x minus 3, we can factor this into x plus 1, x minus 1. So we'll go one more step. We'll go 2x plus 3, and we'll go x plus 1, x minus 1. That's fully factored, okay? All right, last problem, synthetic division, which I think is the easiest problem of all. I'll go slowly though, Katie. It's a matter of just remembering the tricks, but you can use notes, right? Okay, turn the page when you're ready. Ready? Okay, turn the page. Okay, here we go. We are going to take, watch me write this, 13. I'm going to take 2x the fourth minus 5x cubed plus 0x squared plus 4x minus 4. I'm going to divide that by x minus 1, okay? Yeah, where'd the 0 come from?
You need to plug it in because you need to have a place marker.
Couldn't have said it better. You have to have it because you need it as a place marker, right? There's no x squared. You guys see that? So I wrote it in there on purpose, right? You got to have the 0 because it's a place marker. Nicely said, Ben. So let's do our synthetic division. Upside down division sign. The x's become invisible, right? X's are invisible, so 2, negative 5, 0, 4, negative 4, right? So the x's are invisible. We're going to use the opposite of that. Instead of negative 1, we're going to put a positive 1, right? I'm going to put my add line down below. It's my add line. I'm going to put my little remainder box. Okay. And I'm going to start. First step, always just slide down the first term. Just slide it all the way down, okay? So bring down the 2. That's the long way. Nice job. And then multiply. This is my multiply. Okay. Multiply. That times that is 2. Add. Negative 5 plus 2 is negative 3. Multiply. Okay, so I slid down to 2. Nikolai, just watch. Stop drawing. Just watch because you'll see it. Bring it down. That times that makes 2. Then add. Then I'll go that times that makes negative 3, and then I'll add. Okay, see what I'm doing? Okay, so negative 3 times 1 is a negative 3, and then I add. 0 plus a negative 3 makes a negative 3. Multiply. Negative 3 times 1 is negative 3. Add, I get negative 4 and negative 3 makes a negative 1. Multiply, and I get a negative 1, and I add, and I get a negative 5. Okay? Now, nicely done. You did the long way. So, we really are dividing with x's, correct?
Yeah.
And we really did divide by x. We really did divide by x. Even though the x's are invisible. Yeah, did I make a mistake, Cody?
You get a positive.
Oh, yeah, 4 minus 3 is.
Where am I at? Oh, thanks, Cody. Which makes that 1, which makes that a -3. Thank you, Cody. Yep, thank you. Okay, so now, the x's were invisible, but I really divided by an x, so I'm going to have the answer still going to be x's, but 1 less, because I divided by an x, right? Even though they're invisible, I divide an x into an x to the 4th, so my answer is a 2x to the 3rd minus a 3x squared minus a 3x plus 1. But I got a remainder. Thanks to Cody, I have the right remainder. Plus a -3 over what I divided by, which is my x minus 1. There's my answer. Isn't that a nice way to do that? Can I borrow this? Check this out. Isn't that beautiful? Look what she did. She did the long way. Remember I showed you guys the long way? Nice. We did do this one day. Okay, very good. Now, the last question says, is it a factor? So, let me ask you an easy question. Is it a factor? Is it a factor? Okay, let me ask you an easy question. Did it go in evenly?
It did.
Did it go in evenly?
Yes.
No, you have a remainder.
Wait.
So if you don't have remainders, like any kind of division, if you divide something and you don't have remainder, then it goes in evenly, right? So if you have a remainder besides 0, it is not a factor. So it's no. And the reason why is because it has a remainder. Okay, does that make sense? So if you have a remainder, anything besides 0, if it's 0, it's a factor. If it's not, it just doesn't go in evenly. It's not a factor, okay? Is that easy? Okay, so I have a couple of things for you. One, I want you guys to finish up any kind of like homework that you've been doing.